pH and the dissolved oxygen is getting changed, and we can make the record. Then after that, suppose we are getting the pH value is 7 and the dissolved oxygen 2 ppm. That time we start the process throughout the circulations, because our drinking water generally the pH value is 7.3. Suppose I am getting this kind of value on this reactor, then we will take this water, we will go for the other lab for test like which kind of material they have. Yeah, like for the agriculture land they are using the 10 to the power, sorry, not 7.5 pH value. Then what chemical should be inside for using the agriculture land and food industry? Then according to our application we have to pour the chemical there. And but for the general purpose they giving the like the 5-6 example in the back side of your paper how we can do this process. This process it will take 2 hours to 1 day, 2 days, because this is a very slow process. If you are going, suppose I want to put the H2O with the auxiliary acid, then for the characterization of the auxiliary acid is given the detail in the chapter 1. 30 milliliter of auxiliary acid in the 300 liter of the water in the tank T1 will be the result. It will be 0.8 gram per liter of the chemical.
It's not good as the details of the procedure, it's like overview.
It's overview. Then basically the overview of the system, we are using this equipment to purify the wastewater. The wastewater might be come from our city, might be from slaughtering house, chemical process, organic industry, gas industry, even steel industry, because the steel industry also required huge water to make the cold the coming steel, which have the coating of the different materials. So this is the overview of the system. But overall process we are going to monitor what is the pH value, because I remember when I put this one, it was the first time it was 7.6 1 days back, but after doing the stirring and adding the oxygen from downside, now there is some improvement in the pH. Now last I saw the one manufacturing company, they are selling the water, our local, the pH value was mentioned 7.3. Now suppose if I pull this one pH from 7.4 to 7.3, then we can consider this water can we go for the drinking. But before drinking this water we need to check, because we require how much calcium they have, magnesium they have, sodium they have. But like our standard procedures, we are going first we have to controlling the pH throughout our applications.
So you are just like trying to monitor the pH, which is like
finally my
much important.
My final objective to purify our wastewater. Yes, but in the wastewater there are 3 monitoring parameters. First, monitor temperature is required throughout the process, because some chemical reaction is happening. Then there is a chance to either voltage increase or decrease according to the gain of energy, loss of energy. The second point, we are going to calculate the redox voltage throughout the process. For that we are putting the one redox sensor here. This is the redox sensor.
And the readings from where can we take it?
We can see the reading here. Throughout the process, they are releasing the energy 193 millivolt, and our tank solution is 60 liter. This is the redox voltage throughout our process. Before when I just started, it was showing here about the 200, but due to the process change, the voltage is getting changed. And next parameter, we are going to calculate how much dissolved oxygen inside our chemical solutions. And here we are going to get milligram per liter. Then it's 8.9 milligram per liter inside the
pH,
dissolved oxygen. After that, the next parameter is also depend how fast you are rotating the solution, how slow you are. It's depend on the chemical. Suppose you are using some non-volatile material, and if you try to move it faster, then it will not dissolve. Then according to your process, how you want to make the process, then you have to fix your stirrer, then you have to add the catalyst. This called optimized condition as part of the research. Like suppose in the manuals clearly mentioned from data received from the expert. Suppose you are doing this experiment, and after that you make the conclusion that I was rotating on the speed of the 10 RPM, for example 10 RPM, that time I got this accuracy and took the time to purify the solution. This was the time. This is the overall result. And before doing the purifications, we are going to put this wastewater to laboratory and you calculate how much it was the bacteria inside, and after purification how much bacteria we are receiving. That is the overall like higher part of the research and discussions, like how we can using the system. But if you say the all systems, means the only in the one word we can say we are just purify the solution. But behind this is very big like science, like how you are using, how the people is thinking about this.
You are mentioning something about the catalyst.
Catalyst means like some people is putting some in the chemical reactions, the slow process reactions. Suppose if you may expert in the chemical reactions, then you may put some chemical so that they will make the catalyst solutions and they will make the reaction faster. That's I use the catalyst term.
What is this?
Yeah, this is the reactor part. After reactions, this is called the settler tank. Settler tank can be used for two processes. Either you can add the water from downside. Downside I have connected with this is the overall diagram you may see from here. And either you may add the water from downside. Yeah, after doing the reactions, we can purify and we can receive from here. And this is called the overflow tank. This is the only thing.
And this sensor
This is called the temperature sensor.
is only temperature.
Yeah, only temperature for the receiving tank. What is the temperature in the output side?
Is there any indicative reading for the biological contamination?
No, like for the limitation of the system, you can use the three kind of material. Either it will be biologicals, inorganic, and organic. Like the three kind of you can use, but there no indication. Just user have to define like which material you are putting.
No, like we have
The readings.
the readings. Readings.
Reading means in the back side the part of experiment is given. As I said, the pH range we are defined near about 7.5 is the good range. But for this one is we can vary from 1,500 to minus to plus 1,500. But this one no, I don't. There is no record for this one. Just we have to reduce like here the low chemical reaction is going on this reference. We are getting this voltage.
Here we have all the parameters controlled. What about the output measurement like COD, BOD? That's the
This is a monitoring system. Just we have to monitor. We can
So it's no online measurement.
online measurement means just we can
At the end we are going to calculate how much biological.
no
content.
yeah in your software they will just monitor every parameter. Just there is the one software you may see from here. Suppose
No, what he is asking is that how we can check the values.
So outside measurement only.
no before suppose you are going to put these chemicals, then you have to put to the chemical to understand in your laboratory to understand.
Those chemicals
Yeah.
are feed for the bacteria, if I understand correctly. But my question is, we have some waste. All this process, what going to do is this organic compound going to decompose during the aerobic process. So we need to measure initial COD, BOD, and finally what this reactor does. But those measurements we have to do outside, not right?
Yeah, that's called the part of the characterization, this is the process equipment. Another this is called characterization equipment. Yeah, this is a different equipment. For this one, you may have to go for the other equipment.
We need to fill up to this volume, like this so big volume.
Generally, we can work for the minimum size also, but generally recommended to use the 60 liter because it cannot be complete in the 2 hours. Or maybe you have to run throughout 1 day, 2 days. It depends how the bacteria and how the the waste inside.
I still feel like necessarily the volume of this one is different than the big volume for the experiments.
Yeah. Then you may use the water to make this as a waste. Because finally you may use this much of the water, but the thing is that finally we are going to receive from the top because we are believing that they have the more waste inside the solutions. Suppose I fill this one water from here, then we cannot able to take our solution after doing this reaction process.
You mean like to keep it continuous process?
Yes, continuous required, yes.
Yeah, but we are thinking like to make it a semi-batch process.
How the system is running, like first you have to just come and put your samples, then the computer monitor system, it will automatically record the history since morning to evening what's going on, and you may do the other work and just we record what was the initially and how the improvement were coming.
This is actually the feed water.
Feed water.
And we can, let me say, pump it.
Yeah. There is the one pump thing. This is called feeding pump. They are sending the water from here to this reactor. And the second, this is called recycling pump. Where we circulate from here to here like
Where
that.
is this? Where
Yeah,
is
here
this?
is inside.
Is inside there.
Yes. Notation is G1 and G2. It might be mentioned here.
Gas static. These are the good oxygen. These are the gas static pumps.
Yes.
So this up to 12 liter capacity, right?
12 liter per hour.
Per hour.
Yes.
And if you have problems with these pipes, from where we can get them?
The system is under warranty. Even I guess I have there some spares. But if any problem, then we'll staying locally. We can come and
Usually
check.
gas static pumps, the damage is coming to the
Very,
pipes.
very frequently.
Yeah. No problem with changing. The system is under warranty. Yes. We can get it from us. We have those from us.
Can you bring to us, let me say, extra or spare?
I just think extra. No, they are
The damage is coming always with the pipes. For the time being, we have this.